Hello, this is Dr. C, and we're going to look at the life cycle of a thread. Now, threads begin their life as part of object instances. We either create a subclass of thread or create an instance of a runnable object and pass it to the thread constructor. And that essentially gives us a new thread. It takes a call to start to actually transition the thread from new into the runnable state. So think of threads being in one of these four states: new, runnable, not runnable, or dead. So start, bring us to the runnable state. When we are runnable, when we're running and we hit a yield, then that will again put us back in the runnable state. Remember, the threads in the runnable state are in contention for the CPU. Threads not in the runnable state cannot get access to the CPU. Now, when you are runnable, there are a couple of things that can make you not runnable. One is invoking the thread sleep method. So if a thread says, I want to go to sleep for 1,000 milliseconds, then the thread is no longer eligible for the CPU. It is no longer runnable. It is non-runnable. Other things that will take a thread from runnable to non-runnable, which give the thread dynamic world a rationale for being, is when a thread goes to do I/O. I/O is typically much more time-intensive than CPU activity. So a thread that's going and doing an I/O, reading a file, making a network connection, immediately becomes not runnable until that resource, whatever it is, the file, the network connection, is available, which then pushes it back into the runnable state. But when a thread, for example, goes to do I/O, it becomes not runnable. Then the scheduler chooses some other thread for execution that is able to make progress. So in this way, CPU utilization is taken advantage of. The third method for making a thread not runnable is to actually have the thread execute a method called wait. Wait is actually defined as part of the class object and is used in more advanced threading when you're trying to coordinate the activity of threads with a wait and notify mechanism. But for our purposes here, just be aware that there is a runnable state and there is a non-runnable state, and events conspire to move the threads back and forth between those two states. Now, when the run method is over, when your run method terminates or a thread is told to stop, then the thread becomes dead. And notice this dead state has no way out. So once your thread instance is created and it's started, once it terminates via either being directly terminated or the end of the run method, the thread is dead and can never be resurrected, never come back to life, never do anything else. You have to create another instance of the class if you want to have more action from a run method. But that's the basic life cycle of a thread.